Alrighty, I'm Aren. I've been with 1625 as a student at Northern Illinois Innovation. And then I went to Iowa State University and helped start 3928 Neutrinos. And then for 2014 season, I was with 148 Robo Wranglers in Greenville. And then this last season, I joined up with 1296. I needed help more than 148 did as far as number of mentors. So a bunch of good guys, but it was more useful helping out 1296. That's my FRC history so far. So yeah, I was a student from 2005 to 2008 seasons, and then played with a bunch of stuff before that and after that, and just haven't really stopped. So Alan Gregory asked me to do a talk and come up with a topic, and this is usually one of the ones that stumps a lot of people. I'll often go to events and see like, oh, you're okay, I see what you were going for, but implementation was a little on the not the greatest side. That is always the hardest part for new designer people, is the concept of you can pull something out of thin air. And when you have that amount of freedom to pull anything out of thin air, the more direction and realizing your constraints, the easier it sometimes is to arrive at an actual design or conclusion. So this is essentially you went through the strategic analysis and this is what I need to do to win matches. How do you get from that to here's what my robot looks like? So there's a whole lot of stuff for strategy. This is one of the, and it's also weird because it's not very well bounded. You can pretty much go anywhere with it. So, okay, the robot requirements you usually get after strategy meetings are many times broken up into we have to be able to do this, we want to be able to do this. It'd be nice if we could do this. And sometimes people just give that down to the two of need and want. So this last year, in most cases, people put down the need of like, oh, I need to be able to drive around as far as bringing a scoring object from point A to point B. You may have seen some robots that decided not to do that, and they're literally a conveyor from the human player chute to the step, and then they stack, push it down, and keep going. Which that's one of the things the recent expansion of rules has allowed you to do. So I don't think that's ever been the case before, where it's like, oh, it's a viable strategy to not drive. So, and a couple of those robots could pump out a fair amount of totes. And there was also one, we competed in Oklahoma this year as well, one there that had a driving extension ladder conveyor that started on the far bump and then ran a conveyor all the way back. So watch out during your strategic analysis of if a need is actually a need. In many cases it is, but this year technically it didn't have to be. It was a different strategic route to go that direction. And if you pulled off one of those really well, there's a lot of advantages to it, because a later slide will detail it, but like number of times your robot has to do something in a match is you get this long to do the task. Use that time as effectively as possible. So, Simbot Seminar Series, I suggest watching it. That's talks by Karthik for how they operate. He's one of the smartest people I know, and there's no reason as an FRC team for you to not have watched that if you'd like to be more competitive. So, and then as far as the results of that strategic analysis, occasionally are different categories. Like this year you could be a landfiller robot, you could be a human player robot, you could mix and match those, you can be can grabber, of go out there, try grabbing 4 cans. Like those are all different paths to score points in a match. And then, yeah, also realizing that when you pick one of those, you don't know which of those types you're going to be playing with during qualifier. As far as like, oh, if you build a human player robot, there might be more of those than landfill robots. So you might spend all of your time paired up with another tethered stacker and then running out of totes in the human player. So, station. So, determining what to do there, you also have to factor in what you think everybody else is going to do. Whereas how you would fit on an ideal alliance to play a match. So.
And in the past, has it always been, I'll say that distinct, the roles that you could play?
It tends to be, depends on the game. Some games force you to be doing multiple things at once to be good. So what years have you been around? So you played just this year?
Yeah.
Okay, last year was aerial assault, or aerial assist. And it was a game where there was two alliances of 3, and then there's 2 balls on the field, 1 for each alliance. So that meant at any point in time, only one of your robots could be doing something to advance your points, or going to meet up with the guy who has the ball to help you advance points, which meant, oh, one guy's trying to shoot it, what are you doing? Typically for that year it was, you're playing defense. So that was, you had to do both.
Right.
And then, but people did.
There was probably a way.
But people did
play defense.
Yeah, people did discretize it though. There were some people who said, okay, I'm going to be really good at playing defense, but I'm also going to be great at inbounding. Meaning, I can take the ball, the human player throws it to me, immediately spit it to a partner, and keep playing defense again. And that was good for points because every assist capped on was 10 or 20, depending if you had. So that was a way that you could easily contribute points while also swaying the match in your favor from playing defense most of the time. Because good inbounders were not as plentiful as you would have thought. So a lot of teams actually, like, oh, you're a drivetrain, here, help you out, put this on top of like helping teams to become that. It was a very undervalued role, and it was an easy way to get additional points in every match. So it depends on the year, because in the year before 2013, it was the common ones were like run to the human player, get frisbees, run back to the pyramid, shoot them, of just keep running that cycle back and forth. And then there were some full court shooters that just ran over to the human player and just sat there and shot them all. And then there were people who were climbing up the pyramid, and some people mix and match all those, but it typically does end up being discretized some. This year was a really hard year for brand new people because it's like, oh, many times you might be asked to get out of the way, depending who you're playing with, which is a weird one. I think at Dallas, our third partner was, what do? Make stacks of 2. So like, okay, I'll cover that bump in stacks of 2. And then the alliance captain there was a capper of those circuit chargers. And then, but they would either increase those stacks of 2, or we were making stacks of 5 for them. No, stacks of 4.
It was Kleinbots. We were making stacks
Oh, sorry.
of 4. And then
Yeah, Kleinbots, and then 932 was the third. So.
they put it on top.
So, well, no, they were capping our 4 stacks.
Yeah, they were capping on 4 stacks.
So, but the way we had set it up is we were able to make shorter stacks, but at that point in time we weren't completely done, and we never were completely done. So, but we were flexible enough to be able to be like, oh, you're good at capping 4 stacks, and we currently can't handle a can worth anything right now. Here's some 4 stacks, and just like pump out 3 4 stacks for them for the 3 cans, and then here's 2 6 stack, a 6 stack or whatever, of whatever time we have left to make more stacks. So
this game was a little unique in the fact that it was not so. The other ways you could score points were dependent on being able to score the previous value. Other games it's been you can kind of go and score points this way. Add score totes before you could score recycling containers.
yeah.
Well, and it was also unique in that there was no, I'll say, robot dynamic to it. I mean, you could just sit in your corners, the 3 teams did.
Yeah.
You know, we call them left back, right back, and landfill.
Yeah.
And you could have people just play those 3 places and not interact. And you never interacted with your competition.
Right.
And that's, I'm assuming that's pretty unique
That's
for this.
the first year they've really had that. There was one year they did a 4 on 0 of it was 4 robots accomplishing a task as fast as possible and stopping the clock. And the faster you did it, the more points you got. So, alrighty. And this is a weird one, just because optimally your robot can score every toad on the field, get all 4 cans from the middle stack, put noodles in all of them, all by yourself. You can't do that. So what your team can actually do is going to reverse drive some of what strategy you take. So for example, with 1296 this year, we basically went, okay, at the highest levels, if you get all 4 cans from the middle, or you get 3 out of 4, the other guy can't beat you, assuming you can use all of them. But that was basically one of those like, okay, so you need to be the fastest in the world pretty much at grabbing cans. And I initially did I don't want to fight that battle, knowing how many resources that other people could throw at it that we couldn't, person-wise. So it was a conscious choice to, okay, if I'm not fighting that battle, what do I do in order to still be as competitive as possible? And it was, okay, I need to put up the highest score by myself every time in a match that I can. And then it turned into, what's the most reliable way to do that? So that was one of the, like, we couldn't can grab, like, and we decided we weren't going to do it. We were just going to try putting up enough points to seed high enough to grab whoever was the fastest can grabber. So, and then plenty of practice time in bulletproof. Often don't get enough emphasis, and they did not for my team this year.
How early do you start practice?
As early as you can.
But I mean, really.
But yeah,
when do you have to be there?
That also depends. Lots of teams. We built a practice bot. Many teams do, of a duplicate robot, and then that one lets you start doing it later. So, but if you're bagging your robot done, wait till the event. I'd try giving yourself a solid week of literally just practice and tweak and practice and tweak.
If you're building the clone,
yeah,
where do you think it needs to be?
It just ends up being as many hours as you can have driving that thing as possible. Because there's a thing called, like, I think it was like the 10,000 hour mark of like or 1,000 hour mark.
10,000. It's 10,000.
Yeah. But essentially it's like, okay, you drive it for 10 minutes, okay, you're doing okay, an hour you get better. Then once you get to that point, that's basically how far can you get up on that before. Because I've seen some robots where it's like, your robot doesn't look that great, but your driver is awesome. Therefore you're doing pretty well. And then there's been other ones where it's beautiful robot, driver doesn't know how to handle it. So lots of times you see that in off-season events when it's, hey, you're new, here, go drive. And it's like, oh, that's not performing as it typically did. Okay. But the human element's a big part of it. So, but yeah, and then bulletproof as far as being able to do the same thing every match. At Champs this year, I experienced essentially what I call death by 1,000 paper cuts. Like little things biting us everywhere. And the cycle was such that if anything bit us, it threw off that stack cycle, etc. So it didn't turn out too well. So, and then, but yeah, what you can make definitely does impact what route you should take. So this is one of the, knowing what actual resources you have available to you drives that, of mentor Knowledgebase, what machinery sponsors, Knowledgebase period of previous robots, like, oh, I have a lot of experience with six-wheel drive tank, drivetrains. Okay, in this year, yeah, that'll work, okay, go. And basically using that previous knowledge to let you put very little time into something that you know will work and moving forward. We just went with a simple four-wheel drive, direct drive setup, not knowing it wasn't going to be under any real load. So it was a really, really fast, there, okay, drivetrain works, and on to other things.
Like practice. Like practice.
Ideally.
Yeah, ideally. And then obviously, yeah, resources, the amount of time you have. And then also monetary, what can you afford to buy? Ideally, you get to the point where you can build a robot and not really have to worry too much about shooting over, just basically keep it in the back of your mind. But it's quite freeing on the design side to not have to be going, oh, that costs $90 versus, but that's a fun trade-off to play. And then obviously there is the budget cap of $4,000 on your robot per bill of materials. But as far as robot development costs and like buying bulk things for 2 robots, etc., things get expensive. So, and then the bigger you make the above list, the more you can do, but that doesn't necessarily mean you should do that much more. Like, just because you can make a 4-wheel drive independent 2-speed swerve drive doesn't mean you should, because then you go to a regional and you watch a 3-wheel Kiwi drive or a standard 6-wheel drive single-speed tank beat the pants off you because you allotted resources to something that didn't necessarily provide you a competitive advantage. So, one concept, this is the concept I like to take of literally throw the ideas at the wall. Take as many things you can get, and well, everybody, the way I did it was actually just going around the room, like throw a robot concept up there. And we divvied the whiteboard up into 1 foot by 1 foot squares of like, draw a concept, explain it, okay. Every single person fills one of those out. And it's trying to get the idea out of everyone is sometimes fun, because you have timid people occasionally, and that aren't used to it at all. But when you watch a game, most people start going, huh, what, and formulating stuff in their head. So you do get to watch out for, oh, I watched the game, I made the robot in my head, and then just like ignoring all the strategic design stuff, and then...
And the laws of physics.
Yeah, and the laws of physics. So that's why there's the, let everything stick except tinfoil covered monkeys. You can nix those and tell that person to politely leave. No. But the source of the idea doesn't matter. I've had ideas my mother has had, make it onto a robot, because they ended up being the best one. I think that one was actually 2009. We just had a conveyor running for these moon rocks, and the back surface was not grippy enough, so they kept sliding down. And so it was literally like, oh, what if you just cover it in spray adhesive and let it dry for texture? And oh, that works. Okay, done. Like, it doesn't matter where it comes from. Basically, it's get as much as you can on the board, because getting as much as you can on the board lets you see even more. And many times you'll take one chunk from one person's idea and another idea from another guy's and combine them, or tweaks, etc., on that person's design. Which I think on the next one, yeah, take inspiration from everywhere, and that's teammates' concepts as well. Friends and other teams, completely non-robotics related things. I grew up on a farm. There's lots of entertaining implement type things happening, etc. All sorts of things to play with and tinker with. And toys always are full of nifty mechanisms and ways to do things. Like, there's plenty of palletizing robots, etc. this year. So I don't know if any of you guys saw 3310 Blackhawk Robotics. They're Paul Kobili's the team he was with. They built a Fanuc style industrial robot arm that sat between the human player station and the first step and just grabbed a tote and did this number. And it was also biased because Paul used to work at Fanuc. So it's okay, I can make one of these. So
I saw something amusing about 2 weeks ago. I went up to Austin. My daughter's graduating from the University of Texas. The trucks there, they have these big arms. I mean, you couldn't use garbage stuff in this competition.
yeah, what type of game would require that? Yeah, this one.
As
So.
weird as it sounds, it would have been perfect.
So, but yeah, so don't limit yourself to where you're taking inspiration from. I know lots of people just like only look at old robots. Like, those all came from somewhere as well. Or somebody who wasn't looking just at old robots. So, alrighty. So that leaves you with a whiteboard full of squares. So I like going around the room and then going around the room again. And the again is typically useful because people are seeing other people's concepts and tweaking them and wanting to go up and comment on them. But always remember your strategic requirements are king. That's what you're trying to make a robot meet. You're not trying to deviate and be like, oh, well, we could go down this route because this is cool. But in my mind, cool also does have a factor, considering it is a high school robotics competition. If you're not allowed to have fun here, where are you? So, then another tool, 2D CAD feasibility check. Like, you can do simple layouts, literally just a 2D sketch of what your plan is. Like, does this actually fit? Is this possible? And then another one I had, another concept there is 2x4 CAD of, does this fit? And just fast 2x4 mock-ups. We did some of those this year for stackers. And then did this one some. Number of actuators is a good representation, a decent representation of complexity. So basically, it's the higher that number, the more different little things you're going to have to deal with. So obviously if you have, let's say, 2 motors and that is it is your drivetrain, you drive around, it's literally going to pull off making that pretty easily and you're going to drive around fine. Okay? And then as that goes up, it's more things that you need to have the time to go through and design each individual thing. So my preference on number of actuators is like 10, hopefully less, of individual actuators. But and many times I'll combine it, so if I have a drivetrain with 6 motors on it, I'll just count that as 2. It's 2 degrees of freedom. It's right side driving forward and backward, left side driving forward and backward. Like that's 2 on that count. But then that also includes stuff like pneumatics, but those are also simpler than motors in many cases to design for, because it's literally extend, retract, done. It's programming overhead is very low, no control, like very little stuff as far as control loops goes on those. So they don't hurt against the number of actuators as much. And then next is the number of new mechanisms. That's things you have no experience with whatsoever. So for example, this season going in, you could be like, oh, I want a mechanism. I've never done one before. That's more of a risk to you than going in, oh, I've done plenty of tank drives before. If you go with a tank drive, you don't have to put as much development time into it because you know the system better. That doesn't mean you shouldn't go for the new thing. It's another thing to weigh in. So that was one of the, we just chose to go with a simple, like here's 4-wheel drive, tank drive, and then knowing we could flip between traction wheels and omnis on either end, as far as we ended up with 2 traction, 2 omni on that drivetrain to pivot around where the can claw was. But like we were able to play with that, but it was a very low development, construction commitment to build that. So another thing is taking those concepts and figuring out what type of thing can multitask. Many teams this year figured out that a can laying down and a tote sitting there are very similar when it comes to a roller intake. Of if I just do this style intake, I can run into a can or a tote and suck it into my robot. That type of thing is a big advantage because it lets you keep your actuator count down. So, and then you do have to factor in the stupid humans driving the thing. So that one is the, oh, okay, well I just got to do this and hand off this to this, and that is additional complexity that you want to make that driver's job as easy as possible, because the harder you make it, the more practice you have to give them. So it's one of those interesting balances to play. So our robot this year, we ended up with tethered robots, but there is 1 person driving the robot. We have 2 human players loading totes in. The stacker is largely automated considering how simple it is. So.
Is that part of the equation too, whether you use 1 driver or 2?
Mm-hmm. Because depending on what you have to do during a match, the more communication that has to happen, the more occasions there are for mistakes or miscommunications. And obviously if you have 1 person driving and it's all in the one head, there's less of that. But you also need to make sure it's bearable on that 1 driver versus like, and then having button mash instances where it's like, I don't know, and then something going wrong. So it's like, in the ideal world, you have 1 person driving it, or there's also, and then you can find the 2 drivers that are in sync enough and you give them enough practice where they don't even have to talk. So I have been a coach for a set of identical twins driving before. It worked out pretty well. So as far as being in tune with the other person. So 2 drivers, more practice time. So one of the reasons we chose to go and simplify enough to make sure we had 1 driver was that let us load totes faster. As far as 1 guy was just sitting there permanently at the chute door, and then the other guy was handing him totes from the stack. So that was part of our, when we determined that we didn't want to participate in the can war, it was okay, so we're gonna see how many totes we can get out in a match. Our initial strategic analysis was like, okay, it looks like a good robot's gonna be able to get like 15 to 18 totes by themselves in stacks. So, and then that's where a lot of the plateau was. You saw a lot of teams out there capable of doing 3 stacks of 6 with a can. So it was, okay, well, if people can do that, chances are somebody's going to be able to do can grabbing and that. How do we beat that guy? And that time analysis was basically included drive to the human player, pick up 6 totes, drive, grab a can, go to the human player, pick up 6 totes, drive over a step, set them down, get a can, go stack 6 totes. And that's what our time analysis is based around, that cycle. Or grab a can, go through the landfill, get 6 totes, drop it off, go through the landfill, get 6 totes, drop it off. So landfill had 18 right set up totes in it, I believe. So that led to a lot of the, oh, we can do 3 stacks in the landfill, they finish out that 18 totes. So that one turned into we were looking at that, and we just did a spreadsheet for that guy. Let's see if it's, I'm not gonna walk over it. So we ended up doing a spreadsheet time analysis for that guy. It was literally, we have the 2 minutes and 15 seconds, so 135 seconds of that match to move as much stuff as possible, because it was a warehouse game. And we just went through that and said, okay, we're spending all of our time stacking and going and scoring. Like, those are the 2 things taking up the time. And then said, okay, both of those are happening at once, because the human player totes, they came in the same spot every time. So by going through and redoing that time analysis, it was, okay, 30 totes is possible. But you can do it. You can do 3 caps, like with the 3 nearby cans, you could do 3 cap 6 stacks and 2 uncapped stacks. With that cycle, if you were stacking and going to score it at the same time, that's how we ended up with 2 robots, and the cord between them. So, going back to I have a whole bunch of ideas on the board, and I just started narrowing them down based on complexity, etc. You usually end up with a couple strong designs of 2 or 3 concepts leading forward, and you're trying to pick from between those 2. Almost every determination you make should be based as much numerically and data-driven as possible, of quantitative, not qualitative. But lots of times you're moving fast enough to where you get to the point where you can't pick between designs based purely on numbers because you don't have them. And that's when you start prototyping. So, oh hey, how fast can I actually make a stack via a elevator or a 4-bar? What are the determination, like, what are the differences from a driver perspective if you're like stacking from the landfill using an elevator or a 4-bar? And that one turns into just going through motions. We actually just built a 2x4. We called it clicker, as far as click down on a tote, okay, next tote. And we didn't go through prototype any 4-bar stuff, but it was like, okay, so if I'm making a linearly tall stack, it makes sense to just go straight up and down with it rather than 4-bar in and out, and always have to adjust for depth depending on how your stack is. Which that was a determination of this is easier on the driver because of that. So, but prototyping is basically used to give you that quantitative data that you don't have yet to pick between concepts that are currently leading. So. And then nothing is final until it is. But prototyping data gives you a concept to move forward, and then there's also the concept of shoot the engineer and build the thing. Because sometimes you go like, oh, it's the middle of week 4 and we haven't picked what we're doing yet. So you need to keep an eye out for that one. And then lots of times it's, okay, this isn't optimal, go forward and have something. And then being able to make sure that you build that with an account. I have the withholding allowances handy. We took full advantage of that this year. Yeah, we showed up at Dallas with one method of a can lift that involved a handoff between the 2 robots, which was a very poor idea, or at least our implementation was horrible. So we ended up, I think we made 1 capped 6-stack the entirety of the event, and then past that, a whole lot of glorious failures. But we took that opportunity to go, okay, research more on can lifts, and then went through and rebuilt our entire can handling mechanism between events. We went to 3 regionals this year. So I went to Dallas, and then we had a week and a half turnaround to San Antonio and rebuilt an entirely new can lift. And that one, for sanity's sake, we went through and did how do we get a can on top of the stack again, just like from scratch. I have a can, I need to get on the stack with this robot. And I had an additional constraint because I had the existing robot in front of me that I could only make so many changes to with the time we had. So we chose to actually drop from 6 stacks to 5 stacks from a sanity perspective in order to lift a can up and still and still be able to pass a stack through a robot. And we were able to pull that off and get enough practice that it did reward us in San Antonio. We ended up pulling off the win. But withholding on this is very handy, because then we proceeded to do it again. And then again. So, but we ended up not being bulletproof and not having enough driver practice with the final invitation for champs. So that's also a many-edged sword to watch out for. It lets you get better, but it can also make you do worse. So, and this is my favorite picture. This was on the practice field in the pits at champs, not out on the actual competition field. But it can be done. We pulled off 30 totes by following that initial process, by following through that process. And so in theory, if we were able to do this every match, rather than just when everything went perfectly, we would have pulled off our initial strategy of put out as many points per match as possible, pick whoever is the fastest can grabber and go. For example of that working, C148, picking 1114. So they ended up with a similar concept of a tethered robot stacker and going, but final implementation was more polished time-wise. So just this was one of those wrong fields. Supposed to do it out there. So and then I think the last things I have on here are resource. Simbat Summer Series, a friend of mine, Adam Hurd, has done a bunch of videos, because that one of those includes 2D sketching of designing a robot as a 2D sketch. Of many robots, you can just look at the side and design everything out and go, because they just typically operate in one plane. This year's stackers are pretty similar to that. Of from the side, it's okay, tote comes into there, stack, and then he's also got some other ones for general CAD dealings, and then that one just ends up helping you speed up your process. Chief Delphi is a fun one, because you get to sort useful from not. There's a lot of not useful, and then there is still a lot of useful. You just got to be able to find it. So bluealliance.com is a good resource as far as old match videos of going back and seeing what worked in past years, which is, I downplayed it some earlier, but it's still really important. Build Blitz for, we do some stuff for VEXpro. And then that's similar vein in Robot in 3 Days, as far as it is a whole bunch of very experienced people building a robot really fast in the first 3 days, and you get to steal things from them that you didn't know before. So that earlier slide regarding going after something that you've never done before, if you know someone who has, that lowers that risk. If you've seen it work somewhere else, that lowers that risk and makes them more, well, it enables you to follow that through easier, because it's like, oh, I'm having this problem. Hey, what do you do about this? Oh, okay, implement it. Having somebody who's done it before is a great help. So, and that's that, and then my plan is the rest of this is discussion. Also, I have no idea what time it is.
11:10, and if people ask questions,
yeah.
keep the questions so the microphone.
No. So, it's a weird topic. Yeah.
So my question would be, in using electric motors and all the, I'll say, gearboxes and hubs and things like that, you need to do that. Are you limited to VEX and AndyMark, or is there kind of a...
You can do whatever.
I know, but
yeah.
What is that other world? In other words, I haven't found it.
Industrial power transmission industry is huge. It's just lots of it's not optimized for weight or quick changing. These guys are making fun of me a little bit because every motor on a robot was through a versaplanetary. And one reason we did that was because I get them free. The other reason is it lets me change the ratio whenever I want. And we changed many of those over the season because the best concept, well, way to say it is, it lets you be wrong late. Of, oh, I misgeared this motor. Swap. Hey, it works now. Okay, on to the next thing. One place for available components, like stock drive products, is a place. They've got, they also have the nickname out of stock drive products, so you got to watch out for whether or not they actually have it in stock. It's a good idea to call. They have a lot of timing belts, gears, pulleys, all sorts of random motion components. Like MasterCar is your friend if you've never been there. and then well, those are the two biggest ones. But then more little places are popping up.
Ranger.
Yeah, Granger, MS.
If you work for a major company, there's a good chance that they have an account there, and you call them, you go there, you pay for it, and get a big discount.
Yeah, we for work at Innovation First, IFI Vex, we have McMaster accounts, so it's really easy to buy things from there. So, but that's more of an advantage for 148. So, because you don't want to go too niche, because you want to make, because one of the hardest parts is, oh, I need this, and it's typically acceptable for many of those places to be like, oh yeah, that'll ship in 2 weeks, and that's okay to them, and you're sitting there going, but I need it now. So the trade-off on the AndyMark VEXpro stuff is you're essentially trading money for time. It is, okay, I can take this and go now, or I can buy this other item and wait longer, and or have to do more work to implement it. So.
But I assume that you go into your build season, and in November and December, you kind of know what you typically use and mechanisms, and so you kind of load up on stuff and sort through that, right?
Yep. So we did mainly this year, we did sheet metal and tube construction of gusset and tube. Of 1x1 and 2x1 extrusion and gussets. We have a laser sponsor that we're able to have make us a lot of gussets and other various pieces, but it was it's one of the fastest way I've found to build robots. So, because another thing is, like, I know plenty of teams have taken all the Versa gussets we have for VEXpro and just sent sheets of them to their laser sponsor or water jet sponsor and get them back. So it's like, okay, you get the parts at free to you as far as from the sponsor, but it's a fast way to build things. So, but you stack up on that before season and stuff. So, anything from you guys? All professionals.
How long do you spend getting your ideas, putting it on the whiteboard and such?
That process, I think, was 3 or 4 days. Yeah, initially, and then the rebuilds. So, but it's about what it ends up being. And then during that time, you're still bouncing back to the strategy. I can show you some of the simple little things we did. So some of this was like, here's a scoring matrix we did, and this is all based, impossible to see, yes. I don't know how much I'll get if I zoom in. So the concept here was on the left side that says number of times done. That is the number of times that action is completed to get that amount of points, and then it's sorted through the periodic table of the stacks. So in this case, 1 tote, 2 tote, 3 totes, 4 totes, 5 totes, 6 totes of just totes. And then tote and can, 2 totes and can, 3 totes and can. Then tote, can, and litter, tote, can, and litter, tote, can, and litter. So it goes from a one, you can do 20 1-tote stacks and get 40 points. Or you can do 1 6-tote can and litter and get 42 points. So the balance here was, the more times you have to do something, the more times all the other superfluous things in there eat up your time. So if I'm making 40 1-tote stacks, I'm going somewhere, getting a tote, going back to the step 40 times. That takes a lot of time. So points wise in here, you can hunt for some of the sweet spots, but obviously the less times you have to do something, the less time is wasted in transit, etc. So my maximum points per thing is there's 42 of 6 trash can litter. I do it once, it is 42 points. And then, so that is the thing that lowest number of actions, but it also requires you to get a can, get a noodle, get a stack. So there's 3 sub actions in there. So there were some robots that decided to forego the forgo the noodle and just get 6 tote and can, which is 36, but be able to do it more often because they don't always have to run back to the wall to get a noodle. This is just a good way to start wrapping your head around where the points are in the match. So, and then as far as the simple time analysis we did, why do the controls even work? Hard. Who remembers how to zoom in on Google Sheets? I'm used to control scroll wheel being happy. Okay, so time, total time, action. And so in this case it was grab can, drive to whom player, and drop was... Our initial concept actually had 2 robots starting the match on top of each other. And we were accounting for time for that before Sharb.
You can mention it.
This is one of those anybody can have the good idea. So we were explaining it to him, and just because he was not there the day we came up with that, or he got there later. So we explained the concept to him, and then before we finished, he went, "Oh, so you start with one up against the wall and the other one's driving around." It's like, yeah, that. Because the initial concept was drive along, like do a 3-toed auto, score it, and then match starts 3, 2, 1, run over and drop off the stacker, and then go do other things. Because I'm so used to starting a match as here's my robot, rather than, oh, I can just set this there and stretch my other robot all the way over there? Huh. Well, duh. So. And then it was time it takes to load 6 totes, which this is a very fun one to optimize. If you see us running matches out there, there's 3 upside down totes as a table, and then practice on that. Harrison over here is a human player. And then time it takes to go and unload that, so it's number of cycles, 6. In theory, if that cycle ran perfectly, we'd have 21 seconds left. We did some analysis of our time in Dallas, of time in the first 4 stack in the match, which we ended up doing 3 4 stacks, a 6 stack, and another 4 stack in a match. So averaging out that time, seeing where we're at, of where to keep shaving time. So, but being able to look at this and be like, how long does it take me to make the stack is, okay, so I've got roughly 15 seconds or 13 to 15 seconds to take the stack I just got, go score it, grab a can, and then get back to the stacker before another stack was done. So entertainingly, the stacker typically beats the driver of it's ready with a 6 stack before he gets back. But so that puts it back, the pressure back on the driver to keep up with that. But this is the time analysis on that one. And then you can see our little, this is just stupid simple stuff as far as robot requirements. The cube, the stacker, it has a motor for stacking totes and has a motor for intaking quickly from the wall. So we have there's the roller that pulls the tote out of the chute, and then there is the one that stacks, and that's it. It does have some sensors on it. Actuators on our pallet jack, it needs to collect the stack, grab cans, lift can onto the stack, drive, and then initially had deposit cube, which is now a 0, deposit stack, which we combined into the collecting stack, same mechanism. And then pick tote up from ground was one for Auton of being able to stack 3, which we did not end up getting there. But points wise, it was still, that was essentially the next thing on the list after we pulled off doing 30 totes was the Auton. So, but there's nothing fancy about any of this. This is literally just poorly formatted Excel. So, but it was all we needed to do to get, yep, okay, that makes sense. That's where we're going. And those are number driven decisions. So. There was one other in here. No, apparently not.
I had a question on CAD.
Mm-hmm.
How many people do you have CADing, and how do you divide the CAD work in your team?
This year, with regards to CADing the robot, we had several students who had prior experience from classes, and then Chris Cannon, the coach, is also experienced in CAD. So since we had 2 robots, we went, okay, you do that one, I'll do this one. And it was working, so most of the CAD was actually me sitting between 2 students while they were CADing, just bouncing back and forth. And then Chris was working with another couple of guys, bouncing back and forth between them. So the amount of actual CAD I did during the season was pretty small during build season. When we were doing the rebuilds under highly accelerated time spans, I did a lot more. Harrison can vouch for me grumbling, going, we're doing a lot of CAD training this off season, because then you get to do this more. He didn't look too happy. So yeah, I'd say we had 6 students actively involved with CAD, and then me and one of the other mentors working on it. Considerations for what's drawn? Yes. We did have, typically when we start, before we start actually CADing something, we go and whiteboard it. There was one meeting where there was one student who was really good at CAD, doesn't know a thing about design. So we were up at the board going, okay, I'm going to make the stacker out of, here's a piece of 2x1 up the back with bearings on my carriage. Okay, that's got the bars running out and the actual stacker flaps. Then, okay, we'll plan it all out on the whiteboard. Just like, this is a piece of 1x1, this is a piece of 2x1. I do need to brace this. Okay, there's got to be a set of rails that the tote sits on the bottom. We'll go through and plan it out of, I'm going to have this, and then go and CAD that. So the first time we were actually doing this, that one student was off in the corner just CADing away. I was like, oh, stacker's done. I'm like, can't make any of that. Great. But we don't jump straight from like, okay, there's the concept, let's go CAD it. It's do the intermediate step of whiteboard assisted design instead of computer aided design. But that's one of the reasons I like doing the tube and gusset construction, is it's a lot easier to picture for new people. I need for an intake roller, it's like it needs to be X distance, Y distance off the ground. And I have that constraint, and then I need another one back here of, okay, how do you start constructing that? And it's like you get to fill in supports between that. This summer we're working on a Kiwi Drive base for fun / controls development, and it was fun going through this in more depth to, okay, we're going to make it just a quick development one. What's the fastest way to get one of these rolling? And then we said like, okay, bag motor versus planetary omni wheel, 3 of those. Okay, how are we, like, what's the structure of it? And there were times it was like, oh, well, here's this bracket just attached to the frame. I'm like, what's the frame? And then just get blank stares back because they're not at the point where they're pulling frame concepts out of thin air. So before I even start CADing, I typically whiteboard most of it, so it's like I know what I'm going to CAD. It's not, let's figure out how I'm doing this while CADing. It's the step before that. So not too often do I. The only time I'll have to actually CAD determine how I'm actually going to make it is when stuff's like stupidly compact. Like, I don't know if that'll actually fit. So that's a lot of times I use the 2D sketches for the fast initial, like, okay, that will fit. 3D CAD's always like the last thing in that list. It's whiteboard it, 2D sketch it, make sure things are feasible, and then start 3D CADing it. So, hope that answers.
When you do the whiteboarding, what sort of things are you looking for? Like obviously there's game, the ability to play the game, but like you said, you had someone CAD something that couldn't be built. What sort of things did you look for to determine that they couldn't build that, or it was not possible to build that?
This one turns into, well, I think the best way to put it in the words. In terms of FRC design span time, the more experienced people help a lot with that part in terms of what's feasible, what's not. And also keeping in mind what you tend to stick with. So we did a whole lot of rivets and tube attachments. So for rivets, you get to watch out for stuff like they're made to operate in shear rather than tension. So watch out for joints like that. We're planning on putting gussets places. So occasionally it was like, oh, those tubes meet up somewhere where I don't think I can make a gusset to do that. And that sort of thing. That's definitely one of those good experience comes from mistakes. Mistakes come, oh, I'm trying to remember the phrasing of that. It's like experience comes from bad judgment. So make mistakes faster is one part.
Well, let's thank Aren for his time. Does anyone have any other questions?
All right. Sorry. we can chat more later on that. Alrighty.